Hello and welcome to another video by Mr. Educational Services. In this particular video, I'm going to show you how to create widgets and user-defined functions. User-defined functions and widgets are very helpful in any exam situation whereby you want to access some of the rules you may have created very quickly. So it will save you time. So I'm going to first of all create a user-defined function. I'm going to call it sum of, and I'm going to intentionally make a spelling mistake. So instead of the letter U, I've used O because I can go and change it later on. So I'm going to save it as a function and I want it to show in my catalog. Okay, so I'm going to put the letter N. So it's going to be sum of the first N natural numbers. Now you will see in a function I have to use return because that's where the result is going to be returned and not displayed. So I just want the answer there. So result. So now the formula is n times n plus 1 over 2. So I've used the fraction template and I'm entering the rule. That's the output there it will display. So let's go and put first 5 natural numbers. The sum is 15. Let's go and try 100. The sum of first 100 natural numbers is going to be 5050. Okay, now I want to save this. So the file name is going to be UDF for me, user defined function. And within the file, I have a function which will be called sum of. So the file name is UDF. So user defined function. You can call it anything. And then within the file name, I should have this over there. Now let's go to the library document, refresh the library, which is number 6. And it should show in the catalog. Now if I click the book and if I go right down there, it says UDF sum of. So the file name is UDF and the function is sum of, and that gives me the sum of the first 56 elements. Let's do another one. So go through the book and let's do 100 again, or 55. Okay. So now what we are going to do is go and probably change the file name, but let's first try a few more. So sum of the first 100 is 5050. And now if I go into menu, actions and rename, so it gives me the option to rename. So I'm now going to type in sum of correctly and go there, and now it's saved as sum of. So if I go back to the book, I can access that. Okay, the next thing we are going to do is to create a widget. So I'm using the notes page. Now a widget has to be on one page. I can have actually a layout where I can put 2 or 3 pages on that one main page. The first thing now I've done is I have created a point P with coordinates 2 and 4. Now I can't use normal brackets, so I've used the curly brackets. And with the curly brackets, the advantage is I can access each of those elements individually. So I've got 2 points with coordinates, P and Q are the points and the coordinates are in the list. So the first point, that's the element 1, which is 2. I'm going to store that as x1. So point P will have coordinates x1 and y1. So let's store that as y1, and then I'm going to do exactly the same thing for q. So q1 is going to be x2 and q2. So that's the element number. So 1 is in the square bracket, which is the element number of the list. So I'm storing that as x2, and then I'll go and do q2 and I'll store that as y2. And once I have stored that, I can go and change the coordinates at any stage, and I'll show that how we can do that. So what I'm going to just do now is I want to hide all these things. I only want the coordinates to show. So select all of them, maths box attributes, and I want to hide the input. I only want to display the input. So the numbers 2, 4, 7, 11. Okay. We are going to create a first rule, which would be to find the slope. So I'm going to just type in text slope, and now I'm going to use a maths box where I'm going to actually enter the formula. And we know slope is y2 minus y1 over x2 minus x1, which is rise over run. So y2 minus y1. So y2 and y1 are already predefined for me, which I did in the previous step, x2 minus x1. And I can store this as letter m, but first let's go and so let's store it as m. So the gradient for the current points is 7 over 5. Now I can go and change the coordinates for p and q at any stage. Let's go and create the distance formula, which will be y2 minus y1 whole square under the root sign plus x2 minus x1 whole square. So that's the distance formula, and it's going to actually give me the distance now. and it gives me the answer and the exact value. If I want, I can use the approximate option there as well. We're going to create an equation for a straight line. So I'll go y minus y1 equals m into x minus x1. So you will realize I've already stored m, so x minus x1. And later on, I'm just going to go and use the solve option. So I'll go and pick up solve from algebra. So menu, calculations, and go to number 3 and solve. And I'm going to solve for y. So copy this whole thing within the brackets. So I can cut and copy this here. So paste it there and solve for y. Now once I click enter, it should give me the equation in the form y equals mx plus c. Now I'm going to actually also rewrite this equation in the form ax plus by equals c, or ax plus by minus c equals c. So what we are going to do is use the polynomial tools, fraction tools, and I'm going to get the denominator. In this case, the denominator is 5, but because the denominator may change for me, so I'm going to use the denominator syntax, and I'm going to use the right side of my equation, and I'm just showing you what the maths is, but actually I'm going to restore this as equation just now, and I'll make it easier. So that tells me that the denominator was 5. Okay, so let's go and store this now as equation, and instead of typing the whole thing over there, all I need is the equation there. So I've stored this as equation, so I'll get rid of this and put equation over there. So just trying to make it easier and simpler. And so now it's going to get the number 5, and we are saying okay, display that. So it's multiplied the denominator. Now I want to minus the right hand side because I want to bring everything to one side and equate it to 0. So let's go and do that part there. So minus the right side, and let's see what it does. So it gives me everything equal to 0. So that's my equation in the form ax plus by plus c equals 0 or whatever. And now I want to save this. But before I do that, I want to hide the input. So it's only going to display the slope, distance, the equation in the two different forms. And now if I change the points, so the coordinates of point P and Q, I can keep changing, and you'll see it keeps updating the values underneath for slope, distance, equation, and so on. Okay, so that is actually a widget over here. Now, when I save the widget, I have to save it in the widgets directory, which I'm going to just show you in a moment. And when I want to access this widget at any stage, all I have to do is to go and add the widget. So let's go and save it. It has to be saved in the widgets folder. So my widgets, and I'm going to give it a name. So I'm going to call it CG for coordinate geometry. I've saved it, and now to access it, I go and do add widget, and you'll see it shows over there CG. And now when I add, it shows everything. The first thing is I'll go and select everything, and I'll say actions, evaluate selection, and you'll see it looks much user friendly. And now I can go and change the coordinates, and it will just keep updating all the information. So I've changed the x1 value and the x2 value, and it gives me the slope, distance, everything. Yeah, so I can just keep changing to any point. So once again, if I go and add a widget, it will show me there coordinate geometry. Just go and select all, and then evaluate selection so that I can hide all the inputs that I don't want to see. So evaluate, and now I can keep using the thing. So once it is open, then I don't have to do that evaluate selection each time. Okay, so that's the first widget we have created. Let's go and create another widget, and I'm going to access a pre-created widget which was for inverse, so that's already sitting there. And this particular widget, I store a function, and I am going to determine the domain of this function and then the inverse. So you'll see I'm just changing the function to a log function, 3 minus x. So it's got a horizontal translation and a vertical translation, and this will change to an exponential function, and the two translations will reverse. And I've gone and put a dilation from x-axis, which will become a dilation from y-axis in the inverse. So you can see that there, and now I'll go and change the function to something else. So this particular widget is giving me the domain of the original function, and then it is determining the inverse. Now when it's determining the inverse, at times it may give you the domain for the inverse as well, and the domain for the inverse will actually be the range for the original function. So I'm going to put another function there, and let's go and put a cube root function which has a vertical translation of 7. So the inverse should be a cubic, so you can see that x minus 7 whole cubed. Let's go and just copy this, and I'm actually going to check the domain for this. So the domain will be the inverse for the original function. So I'm adding a notes page, and I'm going to use a built-in feature which the CAS already has, which is called domain. So if I just get the domain, I put the function there, which was the cubic for me that I copied. So Control V, and I'm going to do comma X. So this gives me the domain for this inverse. So the domain for the inverse was the range for the original function. Okay, let's go and change this to another function, and you can put any function there. So I'm going to put a function with log 5. So in this case, when I get the inverse, I should have base 5 as the exponential function, and you can see that. And also the horizontal translation has become a vertical translation. Now if I just copy that part there, the expression without the y, and if I find the domain of that, that should give me the range of the original function. So which is obviously negative infinity to infinity. So this widget helps me find the domain of the original function. It helps me find the domain of the inverse, which is also the range of the original function. And let's give one more try. So this is with base 3. So the new or the inverse would be an exponential function with base 3. Sorry, a log function, but you will see it actually does 3 to the power of 7, and it had that big number, but I can go and rewrite that. So 2187 is nothing but 3 to the power of 7. Okay. Yeah. Okay, so you can keep just changing any function there. So let's go and put base E, and it's got a horizontal translation which will become the vertical translation. So you see it goes into the log form. So that's another widget that we have created, and as I said, to access the widget you have to go into the widgets library. Okay, we are going to create another widget which probably is not as helpful, but it actually explains the concept of calculus. So we are going to create a widget for product rule, quotient rule, and the chain rule, and you'll see it actually does it in steps. So I've already created the widget over here. It's stored in the widgets library. I've gone and put a function sine 5x, which is fx, and then I've got another function e to the power of 3x, which is gx, and you can see it shows you in steps. So the product rule and the quotient rule. So this one here is the quotient rule, and I've used the common denominator because I want the answer to be expressed with a common denominator. So you can see that. So I have both the product rule, the quotient rule, and of course right underneath is also the chain rule. You can go and change the functions at any stage. However, as I said, if I know the complete function, I'll just use the derivative template under calculus menu and do that. But this is just when we are teaching the students, probably for them it's easy to understand how the product rule or the chain rule or the quotient rule works. So I've just changed the function, so it gives me the individual derivatives there, and then I go and substitute the derivatives, and that's going to give me the actual answer. So you can see the substitution there. Okay, so that is the product, quotient, and chain rule widget. So what I'm going to show you now are the pre-stored widgets that I have got. Okay, so that's there. So once again, I have to repeat, widgets are very time saving for students, especially in an exam situation. Okay, let's go and store a function fx, and this time I'm going to create a widget for average rate of change and for average value of a function. So I'm going to store my function fx, and it's a quadratic, and then lower bound, because I'm doing average rate of change, so lower bound and upper bound. So I've just stored 7 as a lower bound, and then upper bound, I'm going to assign a value to it, let's say 11. So this is called the assign, which is as good as storing or defining. So average rate of change we know is y2 minus y1 over x2 minus x1. So use the fractions template. So in this case, it's going to be the function value with the upper bound. So I'm going from right towards the left. So the higher value minus the lower value. So upper bound minus the lower bound. So function value with the lower bound. And then in the denominator, the run would be upper bound minus the lower bound. So this is the gradient of the secant. When I say average rate of change, it's the gradient of the secant, which is joining 2 points of a function. So in this case, it's got a positive gradient, which is 49. Let's go and define a rule for average value of a function. Now, obviously, average value also is an area bound by the curve and the x-axis on a given interval. So the interval for me is upper bound minus the lower bound, and I'm going to use the integral template to get the actual area bound by the curve within the upper bound and lower bound. So lower bound to the upper bound, and the area bound by the function and the x-axis. So that's area bound by the function and x-axis, and we are dividing it by the interval. And what that will give me is the height of the rectangle if I was to put a rectangle on the same interval, which should have the same area as the curve and the x-axis, bound by the curve and the x-axis. So let's go and evaluate the selection. Matchbox attributes, hide the input, and now I'll only see the average rate of change and average value. Now I can go and change the values there. So in this case, I want to hide the output. I only want to see the input. So I can change the function at any stage. So let's go and change the function. I've just changed it to 3x squared minus 11x. Let's go and change the lower bound and the upper bound, and you'll see the moment I click out, it updates the average rate of change and the average value of the function. So just a reminder that average rate of change is the gradient of the secant joining 2 points on the function, and the average value of the function gives the height of a rectangle on the same interval as where I'm finding the area of the curve. So once again, needs to be saved in the my widgets library, and to access that, obviously I will add a widget. So let's go and change the function to sine of 2x. Now the response may not be very helpful, so I can use the round feature, and I can actually say round up the answer to certain decimal places, and I've used the round feature saying round this answer to 2 decimal places, and I need to do the same for average value. And when I'm working with sine or cos functions, so my lower bound and upper bound may be in terms of pi, so I'm going to actually go and change the upper bound and the lower bound. So that's just using the round feature, it approximates. So I put the lower bound as pi on 2 and the upper bound as pi, and you'll see now it gives me the answer to 2 decimal places, 0.64. If I change the limits, the lower and the upper limits, you'll see it keeps changing. So the average value is negative, which tells me there's more area under the curve. So save it under the widgets folder, and I'm going to call this as AV and AVV, so average value and average rate of change, and that's there. So now when I go and access the widget, it should show over there. Now once again, it will show everything. So if I do Control A, select everything, then evaluate the selection, then it will hide some of those things that I want hidden, and it makes it look much neater. Now I can go and change the value to half of x, 0.5x. I can go and change the bounds if I want, and I can change it to any other function. So let's go and change it to a log function, and I can actually change the lower bound and upper bound in terms of exponential values or any numeric values. So I can have any function there. Let's go and put base e, so Euler's number there, and if I want, I can go and change the lower bound and upper bound also in terms of e. So I can put any function there, and you can keep seeing that it keeps updating this for me. So that's a widget that I have defined and stored. So just another reminder, widgets are very, very helpful. So I've created several other widgets which I'll share with you, but this video is to demonstrate how to use and access widgets. Thank you for watching the video.